Hey everyone, today we're going to look at pieces of 5-7, which is going to deal with the Pythagorean theorem, and the first part of section 5-8, which is going to start our special right triangles. So what we're going to do is we're going to kind of start with 5-7. Now we're going to kind of go through this pretty quickly because we've talked about the Pythagorean theorem before. Don't forget, Pythagorean theorem is a squared plus b squared equals c squared. And so we're really just kind of briefly going back over that, and then we're going to be talking about a little bit of a new thing and then a reminder of something that we've kind of done before. So when I'm looking at the first thing that's new today is a Pythagorean triple. Okay, all a Pythagorean triple is three whole numbers that work in the Pythagorean theorem. That is it. Three whole numbers, okay? And a squared plus b squared is equal to c squared. So if I do this Pythagorean triple right here, the 3, 4, 5. Guys, this is probably the most common Pythagorean triple. If you can remember this one, that will help you down the line because you'll start seeing it frequently. Okay, so 3 squared is 9, 4 squared is 16. 9 plus 16 is 25, 5 squared is 25. So 3 squared plus 4 squared equals 5 squared. So it works in the Pythagorean theorem. They're all whole numbers. That's all there is to it. Okay, so let's take a look at part A here. I want to find the missing side length. So I'm just going to go ahead and call that X. All right, this is going to be my hypotenuse is here. So that is my C. So I'm going to do a squared plus b squared equals c squared. Okay, and I'm going to do x squared plus 12 squared is equal to 15 squared. Okay. So this is going to be x squared. Now 12 squared is 144. 15 squared is 225. When I subtract 144 from both sides, I'm going to get 81. Square root both sides, I'm going to get that x is 9. So this side length is 9. So 9, 12, and 15 are all whole numbers. So it is a Pythagorean triple. That's all there is to it. They are all whole numbers. Okay? Now, one of the things that I kind of want to point out to you, what is 3 times 3? 9. What is 4 times 3? 12. What is 5 times 3? 15. Okay, so this is a 3, 4, 5 triangle that has been multiplied by 3, or I could say it's been dilated with a scale factor of 3. Okay, anytime you take one of your triples and you multiply it by the same number, or you dilate it by a certain scale factor, you're going to get another Pythagorean triple. Okay, as long as you're getting whole numbers, it'll still be a triple. All right, so multiples of that 3, 4, 5 are still going to be a triple. I can look at this and go, oh, I know that's 4 times 3, that's 5 times 3, so this has to be 3 times 3. I could skip the Pythagorean theorem altogether if I wanted to. Okay, if you do that, please make a note for your work that says triple, because that tells me that you recognize that the three sides of the triangle were a triple, so you weren't worrying about it. Okay, you didn't have to do the Pythagorean theorem because you saw that connection. Okay, let's do another one. Again, we're finding the missing side. My hypotenuse is x, so that's my C. So I'm going to do 9 squared plus 15 squared is equal to x squared. 9 squared is 81. 15 squared is 225. And that's going to equal x squared. Okay, when I add these together, I'm going to get 306 equals x squared. Again, we're going to square root both sides. Now, 306 is not a perfect square, okay? If you try to square root it, it's going to get you a decimal. Guys, there's going to be nowhere in this section where you are going to be allowed to have a decimal, okay? So what you're going to do is you're going to find the largest perfect square that divides evenly into 306, and that is going to be 9. So it's going to be 9 times 34. The square root of 9 times the square root of 34, all of these are equivalent ways of writing the same thing. Okay, now the square root of 9 is 3, so it is 3 times the square root of 34 is going to be this side length. Okay, now, is this a whole number? No, so this is not a triple. Okay, so this question is two parts. One is, what is the value of the missing side? And the other is it a triple? So A, it's a whole number. They're all whole numbers. It's a triple. B, this is not a whole number, so it's not a triple. That's all there is to it. Don't overcomplicate it. Okay? The next piece, wrong way. The next piece that we're going to look at is something that we have done before. Okay, so I'm just going to do really briefly here that this is a reminder. Okay, if c squared is greater than a squared plus b squared, okay, your triangle is obtuse. So what we're doing here is determining, do we have an acute, obtuse, or right triangle? Okay, so if c squared is greater, then it is obtuse. If c squared is smaller, then it is acute. If c squared is equal, then it is right. Okay, so when I look here, my longest side is my C. So this is C. Remember that you need to check because it's not always going to be in order from least to greatest. Make sure you're looking in your list of sides to see which one is the largest. So I'm going to do 13 squared and I'm going to compare it to a squared plus b squared. So 8 squared plus 11 squared. Now, I'm putting a box right here because I don't know what the number is going to be, so I don't know what sign is going to be there. So it's kind of like that old school like gray box that you used to fill in when you're like in elementary school. Same kind of deal. Okay, so I'm going to do 13 squared here, which is 169. And I'm going to compare that to 8 squared, which is 64, plus 11 squared, which is 121. So 64 plus 121 is 185. So my c squared is less than my a squared plus b squared, which means my triangle is acute. Please make sure that you are always writing your c squared first with this because then your sign is going to match what you want it to do. If you read greater than, you're going to think obtuse. But I could write this as a squared plus b squared is less than c squared. And that's still obtuse. C squared is still greater. Does that make sense? But you read the sign as less than. If you read the sign as less than, you're going to think acute. So if you write c squared first, then your sign will match what you naturally think of as the triangle. All right? Again, anytime you have any questions, just make sure you're getting them written down. So now we're going to start the big part of 5-8 that I want to do here. And this is the main part of the lesson for today. Is starting to look at special right triangles. Okay, a special right triangle, there are two. There are 45, 45, 90s and 30, 60, 90s. Okay, these triangles come from the fact that we know specific relationships that we can use an equation for between the length of the leg and the length of the hypotenuse. So when I'm looking at a 45, 45, 90, one thing that I want to make sure that you recognize here is that this is an isosceles right triangle. Okay, because these are base angles, they're congruent, my legs are the same length, and vice versa. My legs are the same length, so my angles are both congruent, so they're both 45. Okay, so that's a big key here, is that it is isosceles. Okay, now I'm going to kind of tuck this over to the side here for a second. And I want to show you where this formula comes from. So what's going to happen is that my hypotenuse is equal to my leg times the square root of 2. If you would star, highlight, circle, whatever on your notes so you know that this right here is super important, okay? But where this formula comes from is the Pythagorean theorem. I'm going to use capital L's so you don't get confused with E's, okay? So if I'm doing the Pythagorean theorem, I'm going to do L squared, so leg squared plus leg squared, equals my hypotenuse squared. All right, I'm going to solve for my hypotenuse. So if I add these two together, I'm going to get 2L squared. That is going to equal my hypotenuse squared. From here, we're going to square root both sides to get h by itself. And I'm going to get the square root of 2 times L squared. This is the same thing here. Equals my hypotenuse. Well, what is the square root of my leg squared? and it's just going to be L. So L times the square root of 2 is equal to my hypotenuse. Well, look, that's what we have down here. Okay, so the Pythagorean theorem is where this formula comes from. All right, so let's take a look at some examples. First thing that I want you to do with every single triangle that we're going to do in this chapter is I want you to label the triangle. Okay, I have two legs that are the same length and a hypotenuse. So we are going to look, number one, we're going to look and confirm what kind of triangle we have. Because in the first set we did with the Pythagorean theorem, we did not know any angle measures, but we knew two sides, so we could do the Pythagorean theorem. Here we're going to check and see, okay, yes, I have a 45-degree angle, so I know that this is a 45, 45, 90. I want to find the value of x. Now, I'm not asked for it, but I know that this side is 7 because, again, it's 45, 45, so it has to be isosceles. But what I'm going to do is I'm going to label this triangle. This is a leg of the triangle. This is an equal leg of the triangle, and then this is my hypotenuse. The next thing I'm going to do that I want you to do every time is write the formula. Hypotenuse is equal to your leg times the square root of 2. Okay, if you label your triangle and then you write your formula, all you have to do is plug in and then use your algebra skills to solve. You can do that. Okay, I promise. I got faith in you. You guys can do this. This is not that bad. So my hypotenuse is x, so I'm going to plug in x. My leg is 7, and then it's the leg times the square root of 2. Is x by itself? Yes, x is by itself. Is 7 root 2 simplified? Yes, that is your answer. That is all there is to it. Don't make it harder than it is. Okay? That's it. So, let's do another one. Again, label your triangle. Leg, leg, hypotenuse. All right? So, when we're looking here, again, I'm going to start by writing my equation. Hypotenuse equals leg times the square root of 2. My hypotenuse is 11 times the square root of 2. My leg is x. I'm multiplying that by the square root of 2. Now, is x by itself? No. So how do we get x by itself? Guys, we get x by itself the same way we would if it was 2x. We divide both sides by the square root of 2. Okay? Square root of 2 over square root of 2 is going to reduce to 1. This square root of 2 over square root of 2 is going to reduce to 1. So I have 11 equals x. And that is my answer there. Okay? So again, as always, if there's questions, make notes on your or write them down on your notes. Okay? Now, those were the two easiest possibilities. So we're going to look at one that's maybe not quite as easy. So again, the first thing that we have to do is label our hypotenuse, label our legs, okay? Now, with this one, we know it's a 45, 45, 90 because these legs are both x. That means they're the same length, which means that my angles have to be 45 degrees, okay? So they cannot be isosceles and not 45, all right? And x has to be the same number because it's within one problem. So again, we're going to label hypotenuse is equal to my leg times the square root of 2. Label the triangle, write your formula every single time. I can't say it enough times. Label the formula, write your triangle. Or label the formula. Label your triangle, write the formula. All right, so my hypotenuse is 3. My leg length is x times the square root of 2. So we are going to, same thing we did in the last problem, divide both sides by the square root of 2. This square root of 2 over square root of 2 is going to reduce to 1. So all I'm going to do is write these in the reverse order. I'm going to write x equals 3 over the square root of 2. Okay, so I'm just kind of flip-flopping here. Because, can I leave the square root of 2 in the denominator? No. Rules of radicals, we have to We cannot leave 1 in the denominator. So we're going to do what's called rationalizing our expression. So we have to multiply this by the square root of 2 over the square root of 2. Okay, remember, this is just 1, so I'm not changing the value of the fraction. Okay, so when I multiply across the top, I'm going to get 3 times the square root of 2. Square root of 2 times square root of 2 is the square root of 4, which is 2. All right, so x is going to equal 3 times the square root of 2 over 2. That is fully simplified. That is our answer. If this was 4 square root of 2 over 2, then we would have to take that 4 over 2 and reduce it. Okay, but since it's 3 and a 2, that doesn't reduce. That's how we leave it. All right. So let's take a look at another one. We have a courtyard is shaped like a square with 250-foot long sides. So the first thing that we're going to do is draw a square. Okay, and we're going to label the sides 250 feet. Then it says, what is the distance from one corner of the courtyard to the opposite corner? Well, does it matter whether I do this corner to corner or this one? No. Okay, it doesn't matter because it's a square, so your diagonals are the same length. So I want this distance. All right. So when I'm looking here, couple of things now. It's a square, so I know this is a right angle. Again, it's a square, so I know these sides are the same length, which means this triangle is isosceles, which means these are both 45. Okay. The other way I can think about that is because it's a square, I also know it's a rhombus, and this diagonal bisects both of those 90-degree angles. So either way you want to think about it, there's a couple of ways you can get there. So the first thing I'm going to do, label my triangle. So now I'm only going to look at this half. This is a leg. This is a leg. Then the next thing, every time, write your formula. Hypotenuse equals leg times the square root of 2. My hypotenuse is x. My leg is 250 times the square root of 2. Now, my directions say leave this in simplest radical form and to the nearest tenth. So here's my radical form. I'm going to add feet because I've got units. Remember that unless your question is asking you for a ratio, which never has a unit, if there's a unit in your problem, there should be a unit in your answer. All right, then we're going to put this in the calculator. For a single line, or for a double line calculator, you just put it in as you see it, hit enter, and it'll give you the answer. For a single line calculator, you're going to do 2 square root, and then you're going to multiply that, do times 250. And this is going to get you 353.6 when we round it off to the nearest tenth feet. All right, so any questions on that? Again, make sure you are writing them down. So what I want you to do right now is go ahead and pause your video and try these 4 problems. Again, remember the first thing you need to do, check, make sure you have a 45, 45, 90 triangle. Then you label your triangle. Once you label your triangle, you write your formula. Then, and guys, when you write your formula, don't write your formula like up here where you can't plug in beneath it and you don't have any room. Write it down here so you have some space. All right. So write your formula, plug in, and then solve for your variable. Okay. Now, part A is a little tricky, and I'll give you a hint that B should be a whole number. All right. So go ahead and pause your video. All right, go ahead and check your answers. Let me scroll down here. Check your answers. Notice, and one of the things that is really important here and that I really want, and where I want you to get to, is that you start seeing the relationship between the length of the hypotenuse and the side lengths. Like here, I have a root 2 in my hypotenuse. So the legs are just a number, okay? Here, I have a root 2 on my leg, so my hypotenuse should be a whole number. All right, so here we get 7 root 2, which is my leg, times the square root of 2. So this is the leg times the square root of 2. Square root of 2 times square root of 2 is 2, so 7 times 2 is 14. When your hypotenuse is a whole number, okay, for your 45 45s, I want you to get to the point where you recognize that if I look here, if I look at my hypotenuse is 32 and my legs are 16 root 2. Well, what do I do from 16 to get to, or from 32 to get to 16? I divide by 2. Then I multiply by the square root of 2. Look, 18, my legs are divide by 2, multiply that by the square root of 2. 9 times root 2. Same thing here. My hypotenuse was 14. My legs were divide by 2, multiply by the square root of 2. They're 7 root 2. So if I have a hypotenuse that's 50, the sides are 25 root 2. If it's 100, then it's 50 root 2. If it's 30, then they're 15 root 2. Okay, I want you to get to the point where you can do that without having to write out the formula. Okay, the first time you're ever doing any of these types of lessons, you should write the formula every time because it will help you solidify the formula in your brain. But once you have that solid and once you start working with it beyond day 2 or beyond day 1, then you can start making those connections and those shortcuts. But for the first day on your first worksheet, I want to make sure you are writing the formula, and plugging that in every time. No matter what, you should always label your triangle. All right. So if you have questions, make sure you get them written down, and then I will see you guys in class. Have a wonderful day.